So you take these together and then you subtract it from the number of valence electrons. Now this, in combination with my organic chemist periodic table, you should be able to get your Lewis structures. This periodic table will help you draw those neutral structures. It's very tricky sometimes to understand what bonds to what. How many bonds does carbon have? How many bonds does oxygen have? Starting with boron. Boron has 3 valence electrons and it will have 3 bonds when it's neutral. So for example, you might see Pf3. Well, boron has 3 valence electrons, so it's going to have 3 bonds when it's neutral. Now, my structure given has no overall formal charge, so I need up here this to equal 3 because I will need 3 minus 3 to get 0 for this overall 0 charge. So if I have 0 lone pairs plus 3 bonds, I will get 3. So BF3 will look like this. As I move to a new column, each column has very similar properties, so I included my favorite elements that are below the first row. Here is the first row, but I also really like silicon, phosphorus, sulfur, and all of the halogens. First and foremost, carbon will always have 4 bonds. Remember that. Carbon has 4 valence electrons. And so, when it is neutral, it will have its 4 bonds. These second electrons to form a bond are coming from another species. So, for example, this would have to be something else like CF4. Let's do that to keep it nice and simple. Notice how I have 4 bonds to carbon, overall neutral molecule. When you see -1, you must then add 1 more electron than its valence electrons. So, for example, we will now take this carbon and give it 4. But now we notice there's -1, so it has 1 extra electron. And then I can fill in the fluorines accordingly. And the carbon is the overall -1 center. Let's use our formal charge formula to double check. We are given an overall -1 compound. The number of valence electrons on carbon is 4. Then we subtract the number of lone pairs plus the number of bonds. Here we will then have 4 minus 5, and that is -1. And we know we have done this Lewis structure correctly. Moving on to the next column, we have nitrogen. Nitrogen now has 5 valence electrons, but if you notice, I'm telling you nitrogen only has 3 bonds when it's neutral. If you can remember this, that it starts to go 4, 3, 2, 1. As we go carbon, nitrogen, oxygens, halogens, then you will be set on pattern recognition for your Lewis structures. But with the formula, again, you can always double check yourself. Now let's take a look at nitrogen. Let's give nitrogen all of its valence valence electrons. Nitrogen has 5 valence electrons. So, whenever you see it in a structure, try to make it have 3 bonds. Let's say you were given NCH3. We would first give nitrogen 3 bonds to the CH3 groups. Then notice nitrogen is overall neutral in the formula given. In the structure drawn, nitrogen is again overall neutral, and we can double check ourselves with the formal charge formula. Right now, we have 0 as our overall charge of nitrogen. 5 is its valence electrons. This number will never change. And again, this is just for help. The valence electron number will never change. Nitrogen will always have 5, like carbon will always have 4. Now, we subtract that from the number of lone pair electrons. Nitrogen has 2. 1, 2. And then we add that with the number of bonds to nitrogen. 3. 5 minus 5, 0 overall. Moving to the next column. Oxygen. Oxygen has 6 valence electrons. Notice more valence electrons, but the number of bonds that it likes to have decreases. One trick for remembering this: as you keep going to the right, your atom becomes more electronegative. That means it does not want to share its valence electrons. So although oxygen has more valence electrons than nitrogen, it wants less bonds because it wants to keep more of its electrons. Very stingy. So for example, when you have oxygen in your formula, oxygen will have 6 valence electrons, but it likes to have its lone pairs, but it will only like to make 2 bonds. For example, the most common example, H2O. We know that oxygen has its 6 valence electrons, but with hydrogen has 1 valence electron. It will make 2 bonds. Now moving on to the last column. Here we have the halogens. Halogens now have 7 valence electrons. However, they will always make 1 bond when they're neutral. Just like we saw previously with BF3 and CF4. All of the halogens will behave the same. So that's like BCl